Welcome to our unit on working with quadratics. A quadratic is a particular type of polynomial. So to start off our unit, we need to learn a few things about polynomials, what they are, what kinds there are, and how to simplify them. Let's start by defining some key terms related to polynomials. A monomial is an expression with only one term. 3x squared, 7xy, and 9y cubed are three examples of monomials. A polynomial is an expression that is the sum of two or more monomials, which we can refer to as terms. There are two particular categories of polynomials that you need to be familiar with. First, a binomial is a polynomial with two terms. This is easy to remember if you notice the prefix bi, which means two. A bicycle runs on two wheels, and binoculars have two magnifiers to look through. Notice that 3x squared minus 16 and 9y cubed plus 7xy each have two terms, so we would call them both binomials. A trinomial has three terms. Again, you can remember this easily if you look at the prefix tri. A tricycle has three wheels, and a tripod holds things up on three legs. Notice that this polynomial, 3x squared plus 7xy plus 9y cubed, has three terms, so we would call it a trinomial. Although there are prefixes that mean 4, 5, 6, and so on, anything with more than three terms we simply refer to as a polynomial. Before we start to work with any polynomial, we want to simplify it. We will look at multiplying terms together in our next lesson, but first we need to look at how to add them. Like terms are terms that have the same variables, and those variables have the same powers. This is because, in a way, the variables and their powers define what the terms are. This matters because you can only combine things that are alike. For example, if you have 3 pineapples and 2 pineapples, you can combine them to say you have a total of 5 pineapples. This is just like if you had 3p plus 2p, you can add them to get 5p. However, if you also have 4 coconuts, you can't combine them with the pineapples. You have to just say that you have 5 pineapples and 4 coconuts. This is like if you tried to add a 4c to the 5p, you would have to just write it as the binomial 5p plus 4c. You'll notice that when we illustrated the situation using variables, we used a number in front of the variable to tell us how many we had. This number is the coefficient of the term. When we combine like terms, we simply add the coefficients to find the total number of that term that we have. This is what we did when we said that 3p plus 2p equals 5p. 3 plus 2 equals 5. So now let's look a little closer at identifying and combining like terms. I want to finish this unit by looking at pairs of terms that are not alike, and then looking at similar pairs that are alike and how we could combine them by adding the coefficients. Let's start by looking at x plus 2 and x plus 2x. Notice that since both terms in the first one don't have x's, we can't combine them. However, if the 2 were a 2x, like it is in the second pair of terms, they would be like terms, so we could combine them. 1x plus 2x equals 3x. Next, we can see that 3x squared and 9y squared have different variables, x and y, so we can't combine them. In the second pair, however, both terms have x squared, 3x squared and 9x squared, so we can combine them. 3x squared plus 9x squared equals 12x squared. In the third example, 7xy plus 7x, one term has both an x and a y, while the other term has only an x, so we can't combine them. In the other pair of terms, however, both terms have xy, so we can combine them. 7xy plus 7xy equals 14xy. Finally, 5x squared y plus 6x squared y squared both have x and y, and both x's are squared. However, y is to the first power in the first term, and it's squared in the second term, so these terms are not alike. If we make the y squared as well, like in the second pair of terms, we have all the same variables with all the same exponents or powers. So we can combine the like terms. 5x squared y squared plus 6x squared y squared equals 11x squared y squared. Notice in all of these examples, when we add the terms together, it doesn't change what the terms are. For example, when we add an x and a 2x, we still have x at the end. When we add x squared and x squared, we still have x squared at the end. An xy and an xy is again just xy. And finally, x squared y squared plus an x squared y squareds just give you x squared y squareds. Notice the exponents don't change and the variables don't change. This is important to remember, especially as we go on to our next lesson on multiplying with polynomials. But now that you've learned some basic terminology and how to combine like terms, take some time to do the activities to practice on your own.